Here is the solution to the first thinking problem from the set of 4. Well, if you have not seen or watched the video on the set of 4 which comes before this, then my recommendation is that go through that video. There are 4 questions, all 4 of them are related. This one is the first in that series. Solve those questions yourself, take it as a test. Once you have done your solution, then you look into my suggestions and solutions. So here is the first one for you. T1. Show that the instantaneous rate of change for f of x equals to x plus 2 divided by x minus 1 is always negative. Always negative. So we are not giving you any particular point here to find instantaneous rate of change at that particular point. Now you have to do a general solution, and the result of that general solution should be negative, right? And then only you can say, well, it is always negative. Always negative in its domain. This function is not defined at x equals to 1, and so you cannot find instantaneous rate of change at x equals to 1. Remember that. So restriction here is that x is not equal to 1, right? When dealing with rational functions, it is good. It's good practice to write restrictions, okay, first, in the very beginning. Let's start with that. Good practice. X is not equal to 1, but x belongs to all of the real numbers for our question. Okay. Now to find instantaneous rate of change, we will use the general method, the difference quotient method, correct? So instantaneous rate of change, let me use this term, instantaneous rate of change, IROC, in general is equals to f of x plus h minus f of x over x plus h minus x, right? Where x is point of our interest and h is a point very, very close to x. Generally, we take h is kind of equal to, let's say, 0.001. If we take h equals to 0.001, we get a result which is accurate to 3 decimal places. To 3 decimal places. I am taking this opportunity to explain you a few more concepts as we move along. Okay, now that's a way to do it. Now there is another definition. Instead of saying h equals to 0.001, some people can take h equals to 0.0001, more accurate, right? So like that, what we say, well, our h actually approaches 0. It's very, very close to 0. Another way of writing this is limit of h as it approaches 0. So these are different ways of writing the same thing, you know. Some of my students are not familiar with this limit concept, and therefore I'm trying to give you here. So I will use this concept of limit to find instantaneous rate of change of our function, right? So basically, I'm not saying my h is 0.01 or 0.001 or what, but I'm saying my h approaches 0. It's almost 0, right? And I write like this, limit lim and h approaches 0. So that is the meaning of limit h approaching 0, correct? So that's the starting point for us. Now, since we don't have any particular point here, we will treat x as any point in the domain, but x is not equal to 1. Is that okay? So we'll do it like this. Now let's write our function in the form of x plus h. That means f of x plus h means I'll replace x with x plus h, right? So we say limit h approaches 0. That means this point is very close to x, very, very close to s. Whenever we find slopes, for that we need 2 points, right? They may be far or close. For instantaneous, they have to be very, very close, right? So f of x plus h is x plus h plus 2. I'm writing f of x plus h first, which is x plus h plus 2, right? Replace x with x plus h. That is the whole idea, right? So we replace this x with x plus h. I got x plus h plus 2 on the numerator side, and in the denominator I get x plus h minus 1. So this is my f of x plus h minus f of x, which is the same function, right? X plus 2 over x minus 1 divided by x plus h minus x. So x and x becomes 0, I get h. So I'm writing h. Correct? So that is how I get my expression, right? Now I need to simplify it. To simplify it, I will take common denominator, cross multiply. Do you see that? And then solve it. So I get limit h approaches 0, and then I can write like this. H, this when multiplied comes in the denominator, so I'm writing straight in the denominator. We got x plus h minus 1 times x minus 1. That's my denominator. Now this gets multiplied with this, so let me write this as x plus h plus 2 times x minus 1 and minus of x plus 2 times x plus h minus 1, correct? So that is how I do it. Now here I will expand and simplify it. So my variable limit h approaches 0, and in the numerator I'll multiply each term one by one and see what do I get. X square minus x, when I multiply x with all those things, I get x square minus x. Then with h I get xh minus h plus xh minus h. With 2 I get 2x minus 2. 2x minus 2. So this is for all these, right? And then I've got minus of all this. X times x square plus xh minus x. 2 times all this will give me plus 2x plus 2h minus 2. Correct? All this. And in the denominator I have h times x plus h minus 1 times x minus 1. Correct? Now let's see how can we simplify it further. Now you will appreciate that whenever you do these rational functions rate of change, that step seems to be very complicated. But when you come here, it becomes simplest of all. All these terms on this side will probably cancel. Let's see how. Let's start one by one. X square minus x square, so it becomes 0, right? Do you see that? Correct. Now we have minus x and minus x, 0. xh, right? Do you see that? Okay. Now some will not, right? So some will not. So we'll leave those which don't, but we need to check if that is true, correct? Okay. So this didn't. Okay, leave it. Now 2x plus 2x and plus 2x, and this is minus of plus 2x, they also cancel. Minus 2 and minus 2 also cancel, correct? So what happened really was that all these terms cancelled and we are left with just few terms here. In fact, we are always left with these terms, right? So I'm telling you this because it may look very complicated, but really simplifies to a very simple expression. So we get limit of h approaching 0, and what do we get here? Minus h minus of 2h. So that is what we get. So minus h and minus 2h gives minus 3h. So we get minus 3h over h times x plus h minus 1 times x minus 1, correct? So that is what we get. Okay. So this is the term. See which term is left for us. So we had this h extra here, right? This is different one. So that term, I'm just highlighting these to you because these two numbers are different. Their bases are different, right? 2 and 1. So that is the reason we are left with just these two terms, and all other terms kind of cancels out, right? So that is the reason. So minus 3h and this. Now here you will find that h and h will now cancel, right? They are same factors in the numerator and denominator, and so they cancel out. So we are left with limit of h approaching 0 for our function minus 3 over x plus h minus 1 times x minus 1, correct? Now we can plug in h almost 0, right? So we can just forget about it, or plug in 0. So we get what? In the denominator, we get x minus 1 times x minus 1. And the numerator, we have minus 3 over x minus 1 whole square. Do you see that? So we get something which is like minus 3 divided by x minus 1 whole square, correct? Do you see? Denominator will always be positive because it's a square, right? And numerator has got this minus 3. So it will be always negative, the whole expression. So what we land up with, that instantaneous rate of change for this function in general can be written as minus 3 over x minus 1 whole square. So that is what we get. Now look at the question. Show that the instantaneous rate of change for f of x is always negative, right? Where x cannot be 1, x cannot be 1. So you see, if I put any value to x, denominator is square, so it is always positive, but we have minus 3 on the top. That shows that the instantaneous rate of change of this function is always positive. Do you get the point? So therefore, we can say instantaneous rate of change for f of x at any point is always positive, right? I should write in its domain, correct? So that is how it is proved, right? So what we will do is, in the following examples, I should say questions for you, T3, T4, T2, T3 and T4, we are going to use this formula. We will not derive this formula again, okay? So remember this, we are going to plug in straight away this formula saying that instantaneous rate of change for the function f of x equals to x plus 2 divided by x minus 1 is minus 3 over x minus 1 whole square, correct? And then we'll go on with it, correct? Now there are a couple of questions which come to my mind and I can ask you here, I think. First question is, what really happens to the instantaneous rate of change as x approaches infinity? Can you tell me that? The question here is, how do the instantaneous rate of change as we move as x approaches infinity, positive infinity or negative infinity? Let's think about infinity. So question number 1, communication question number 1 I should put here for you is, how do the instantaneous rate of change changes as x approaches infinity? That's my first communication question. Question number 2, communication question 2 is, from here, can you find a point where instantaneous rate of change is let us say 1? Okay, let me write that. So find a point on the graph of f of x where instantaneous rate of change for the function is, let's say, minus 1. Okay? You know, it can never be plus, right? So it has to be minus. If I write plus 1, then the answer is there's no point in the domain, since instantaneous rate of change is always negative, correct? To do this, what you need to do is you can plug in minus 1 here and then find out your answer, okay? So what could that point be, right? It could be radical or things like that, doesn't matter. Just figure out what that point is. I know it's kind of a radical, but that's what I gave you. So what to do now, okay? So figure that out, okay? Thank you. And let's move on to question 2. And we will remember that we'll use this, apply this formula there. Okay. Thank you. I hope you understand and appreciate it. Share your comments. Thank you.